at all these investments that enterprise IT organizations have made, yet this, the utilization of compute resources in the enterprise is still sub 10% on average, and there's organizations that are still relatively slow, especially when it comes towards delivering applications online and delivering applications over the internet. I think there's still a lot of slow-moving parts in enterprise IT, and I think this is where this particular area around utilization, optimization, and the delivery of applications is where the enterprise can really learn from what the consumer companies did in the cloud space, and I think that's really what kind of, as we're going to narrow the focus of this conversation. Again, if you look at data synapse historically and the notion of shared and dynamic infrastructure, I just wanted to kind of talk about a little bit before we kind of dive in about how much kind of experience we really have in this notion of shared and dynamic infrastructure. When we talk about some of our customers who have 10, 20,000 core, grid HPC environments, one of our customers here is listed here. These guys really, they were able to, on the same amount of commodity hardware that they were running before they engaged with data synapse, was able to do 4 times more trading and 25 times more modeling and simulations. And modeling and simulation, as everybody knows, is a very compute-intense set of activities. These guys were able to do 25x on the same amount of hardware. And obviously there was a bunch of business events that were able to leverage that and take advantage of that increased capacity. But I think that what we were able to learn was clearly that, well, first, that grid computing isn't a universal solution, right? For us to do the work that we talked about around taking HPC and grid environments and scaling risk management and pricing and trading applications across 20,000 cores, that workload clearly needed to be something that was easily parallelized. So I could take a concrete piece of business logic and spread that out across 20,000 cores, and then aggregate the results and the inputs into something meaningful. But our customers, these customers who we were building these grid environments for, were really asking for cloud, is what they were asking for. Because they came to us and they said, hey, can I run my standard web apps on that same type of grid infrastructure? Well, no, right? It's going to take some more innovation and some more investment from our part because web applications running on standard Java EE application servers are not easily parallelized sets of workloads. Can I run packaged applications? Kind of the same answer. And legacy, kind of some of the same answer. So the notion that that grid was universal was wrong, but I think what we've seen is a natural evolution going forward. Over the weekend, I was practicing my presentation, and I was doing some Google searches on some of the keywords in my presentation, and I ran across this quote, which I think is kind of the perfect kind of model for this conversation, and I think it sets up the rest of this conversation very, very well. So, I think that anybody in this field who's interested in cloud computing, who is has been working in this space and in this market for either on the vendor side or the consumer side or the enterprise side, has probably looked at The Big Switch. It's a very interesting book. I highly recommend it if you haven't read it. But Nick Carr, who wrote The Big Switch, was quoted in a McKinsey magazine article that I read. And it was an article that was talking about cloud computing, and I think that in The Big Switch, Nick Carr makes this point that the cloud is akin to what the electric grid was, 100 years ago. And when people started to leverage, ubiquitous and centralized energy supplies, it created this mass wave of innovation that drove the global economy to new heights maybe that were never thought of before. But the quote that I really love is, in the end, it's what you plug into a utility system that is